Good morning. 10 gigabits per second, 15 gigabits per second. Those are the numbers right now that we're talking about as we plan to deploy DOCSIS 3.1 in this decade using 1.2 and 1.7 gigahertz plants. And that's exciting, and it's going to happen, and we're happy to be a part of it. But if you're like me, you may be wondering a little bit about what comes next. What do we do in the 2020 decade? What do we do in the 2030 decade when we might need a little more bandwidth? And we've been thinking about that quite a bit, and we think there's some good things we can do. Perhaps we can get to, maybe we can push DOCSIS up to 50 gigabits per second, 100 gigabits per second, or 200 gigabits per second. Sound crazy? Maybe, but maybe not. Let's take a look at a few things here. So here's a chart you've never seen before. Years along the bottom, along the x-axis, 1982 to 2030, about 50 years, and the y-axis contains the maximum bandwidth, starting at 300 bits per second in the early days, very humble, and potentially going up to 100 gigabits per second by 2030 or so. Now, if we overlay on this chart a horizontal line that indicates that 10 gigabit per second rough limit that we talk about with DOCSIS 3.1 and 1.2 gigahertz systems, you can see those two lines cross somewhere in the mid-2020s. And that's good. That means we've got a decent runway ahead of us, but it doesn't run forever. Eventually, it runs out of gas somewhere in that 2020 timeframe. So the question is, what will you do? What will we do as an industry? Well, there's a couple potential paths you can take. One of them is to abandon HFC, move to newer technologies, things like PAN, Ethernet, point-to-point Ethernet, switched Ethernet. Wonderful technologies. Many MSOs will use them. And that's great, and we are supporters of that. We're building products for that, and we think needs to be in our toolkit and should be in the toolkit. But there's another approach we can take, maybe a little more controversial, but that is to extend the capacity of the DOCSIS and HFC network that we've been working with for over 50 years. And there's some ways we've been thinking about doing that. If we could, for example, take that 10 gig limit shown in the slide here and move it to 100 gig or 200 gig, it pushes that green line up, and you can see it crosses that blue line much further into the future. It could take us out into the 2030s, maybe 2040. So that's kind of exciting. That's something that we want to look at with you today and see what is there to this extension of the cable plant. So the honest truth is, we got this idea a little bit when we did a paper last year that looked at how the telcos have evolved. And I know they're the evil empire, and you know, they're bad, but we did learn a few things when we looked at what they did in 100% honesty. And what they did is kind of amazing if you think about it. They took a 100-year-old twisted pair cable, copper cable, and somehow it was limited to about 1.5 megabits per second in 1995, and through magic, they extended it to a gigabit per second broadband system that they're running over that 100-year-old twisted coax or twisted pair today. That's about a 700 times increase over a 21-year period. Allow them to extend the life of their infrastructure, allow them to provide broadband services, in addition to moving to PAN. So it gave them a lot of improvement and a lot of flexibility in when they could choose to move to PAN. So the question is, can we do the same thing with our HFC network, where instead of using twisted pair with its limitations, move to coax, which has much less limitations? How did they do that, though? They stretched the fiber. They made their copper or their copper portion of the network much shorter in length, which reduced the attenuation in that hop. They also increased their spectral widths continuously throughout that 21-year period. And then they did something that was a little bit counterintuitive. They actually decreased their modulation orders. You know, they went down from 128 QAM to 64 QAM to lower. And that's kind of interesting. It's, you know, you may say, well, why are they doing that? That's a bad idea. But actually, working together, those 2 points can do wonderful things for us. And that's what we propose to do in the HFC plant. So can we take that lesson and apply it to our own systems? The answer is yes, we can. We could, for example, take a system that has a CCAP chassis in the head end, run over a fiber system, but don't stop that fiber, you know, at the typical fiber node of today. Run it all the way to the tap, which is in the top of this picture. And that tap then might have 4 coaxes running off of it. Those coaxes might only be 150-foot coax, so not as much attenuation there. You can also do it fiber to the curb, where you'll have a lot of homes on it. And then you want to increase the spectrum on that to like 6 gigahertz or higher. So you'll have a problem with upstream DOCSIS bandwidth with OBI, but there's fixes for that now. For example, the AgileMax products that are part of Aris's product line. And you can also spread your wings and use this in a distributed access architecture where you have a node-based CCAP box. So it can be used in a lot of applications. But will it work? Well, I.M. Albano will tell us a little bit about that.
Yeah, thanks, Tom. So for the demo today, we brought in a key site function generator that has a recording of a DOCSIS 3.1 signal that was created from an E6000, an Eris E6000 CCAP platform. This DOCSIS 3.1 signal has a 96 megahertz in bandwidth. The function generator upconverts the signal to 6 gigahertz center frequency. And the signal gets transmitted through a coaxial cable that is 150 feet of length. It gets received by a key site vector signal analyzer. So let's take an output, take a look at the output of the VSA. So you can see here, this is the OFDM signal, and these are the continuous pilots. And the dense area here is where the PLC would sit within the OFDM signal. You can see that this is a 96 megahertz signal, and it is centered at 6 gigahertz. This is the constellation of this 4K QAM signal, and you can see it is a clean constellation with an MER value of 40 dB. This MER value is high enough to enable the transmission of this 4K QAM signal with 0 code word errors. So you can actually tell from the results of these experiments that the system is actually working with error-free performance.
So we have a lot of confidence in this experiment that it can work over the coax. We have another team looking at the optical portion. We'll share that with you on another time, but hint, it seems to be working well there, and OFDM has a lot to do to help with dispersion. So the question that may run through your heads is 6 gigahertz the limit? Can we go beyond that? Well, we wanted to take a look at that, so we did some studies, theoretical studies. Here's a picture of frequency along the x-axis, and this shows the bit loading of the signals. This is for a 500-foot drop coax, much longer than most people would ever have, and you can see that we can actually get out to about 5 gigahertz before we have so much loss that the signal-to-noise ratio only allows us to run with BPSK. But if you have a more typical 150-foot drop coax, like I am at in the experiment, like most people have at their homes, you can go all the way to 25 gigahertz or higher, and you can have up to 32 QAM there. So if you do the math and do the integration and figure out how much actual throughput there is for those curves, you can see it on the bottom. This is frequency versus throughput. Our demo ran at 6 gigahertz and got about 50 gigabits per second. And as you slide to the right, you can get to 12 gigahertz, you get to 100 gigabits per second. You get to 25 gigahertz, you get to about 200 gigabits per second. So how could this be beneficial to us as an industry? Well, it gives you higher bandwidth capacities, and that's beneficial. It matches what your customers demand. Increases the lifespan of your plan, allows you to reuse equipment that's already out there. Reduces costs because you don't need to pull fiber all the way to all those homes. You can do it with selected homes that maybe you run PON to that are high bandwidth users. So our key message, DOCSIS 3.1 plus extended spectrum plus OBI-free HPON plus really deep fiber can yield very high amounts of bandwidth that it will carry into the 2030s and beyond, and they do it with the existing equipment. So I'll leave you with one final question. If you did have a 50 gigabit per second infrastructure, and you do, when is the right time to abandon it? Would you do it after 5 gigabits per second of it's used, as with DOCSIS 3.0, or 10 gigabits per second with DOCSIS 3.1? Or would you wait until you're using all of it, which you might be able to get to with extended spectrum? All the answers are good. Any different MSOs will choose different answers, and that's fine. But we just want you to be aware of that third option as you move forward. So I thank you for your attention. We hope to see you at the booth. Thank you.